Good evening, students. Today, I will explain lesson number 2 of IGCSE Physics 06 to 5. This is chapter number 2 of Unit 1, General Physics. So, the chapter name is Motion. So, basically, physics is divided into different branches, and there are two branches of physics which are kinematics and dynamics. In kinematics, we discuss only motion of the objects without any reason. But in dynamics, we study the motion as well as causes behind the motion. So chapter number 2 is belong to kinematics. We will discuss in this chapter we will discuss only distance, speed, velocity, acceleration and speed time graph. So and distance time graphs. So let's start our lesson. The first definition about motion. Objects change its with respect to surrounding, change its position. I should write here the position. The objects change its position with respect to surrounding. That is called object is in motion. If it is doesn't change its motion or its position about with respect to its surrounding, then the object will be at rest. So physical quantities we have discussed in last lesson. Physical quantities divided into base quantity and drive quantity, and physical quantity also described in the form of vectors quantity and scalar quantities. So what are the vector quantities and scalar quantities? Vector quantities are those quantities who have magnitude as well as direction. But in scalar quantity, we can we can explain everything about the quantity with respect to its magnitude only. For example, what is the distance between the point A and B? So it's 5 kilometer. It's a scalar quantity. So length is a scalar quantity. So what is the distance between point A and B in which direction they belong to? So that is a vector quantity. So when we attach the direction with magnitude, that is called vector quantity. So in this chapter, we will discuss the different scalar quantities and vector quantity. And you have to understand that give all the quantities about scalars and vectors. For example, there are many vector quantities, there are many scalar quantities you have studied in many units. So vector quantities are force, momentum, acceleration, all are vector quantities. There are many examples, displacement. So scalar quantities, all the base quantities are scalar quantities. For example, length, time, mass, work done, energy, all are the scalar quantities. They don't need any direction for their explanation. So first of all, we will discuss when object move with respect to its surrounding. So it change its position. It's mean it covers some distance. So what is distance? Distance basically the length between 2 points only. The length between 2 points is a scalar quantity. For example, what is the distance between point A and B? It's 5 kilometers. So it's only length. So it is a scalar quantity. What about displacement? Displacement is a shortest distance between 2 points. So when you see the diagram, so this is your house and this is your school. If you follow this red line, basically you cover the distance. But if you follow this blue line, basically this is a displacement. Displacement means the shortest distance between 2 points in specific direction. So it is a vector quantity. Both distance and displacement are measured in meter, kilometer, centimeter, but the system international unit, which is base unit, is in meter. For example, whenever you try to solve the different questions about different problems in physics, you will convert kilometer into meter, you will convert centimeter into meter. Meter is a base unit. Okay. Next, the speed and velocity. Similarly, speed is a scalar quantity, velocity is a vector quantity. Speed don't need any direction for its explanation. Velocity need direction. for its explanation. For example, the distance per unit time, or you can say that the rate of change of distance is called speed. For example, a car is moving with 80 meter per second. So that is the speed. What about velocity? Displacement per unit time, or you can explain the rate of change of displacement. Displacement is a vector quantity, so velocity is also a vector quantity. So this is the example of velocity. A car is moving with 50 meter per second its speed and towards the north. That is the direction. So it is a velocity is a vector quantity. So how can we calculate speed and velocity? The same formula, same unit. In physics, the quantities which have same unit are the same quantities. So velocity and speed we can take as same quantity. It's only difference of direction. So what is calculation of the speed or velocity? Speed or velocity is represented by v. V is equal to distance over time. The rate means divide by time. So distance is represented by d and time is represented by small t. Symbols are very important in physics. So we can describe the unit, the distance have a unit in meter, I explained, and time, the SI unit of time is second. There are many units of time, but the SI unit, system international unit, is time or is second. So you can explain by formula distance, meter, time, second. So you can write in many way, just like meter per second, or meter per second. So if you know the two quantities, you can find the third quantity. For example, time, speed, distance. You have to understand one formula. You can find different quantities by using this formula. There are many explanations about speeds. For example, sometimes we find instantaneous speed, sometimes we find average speed. Let's suppose a policeman checking your car speed, that is called instantaneous speed. The speed at any instant. And what is the average speed? Whenever you traveling from point A to B and you reach at point B and you calculate your speed, that is the that is the average speed. For example, V average is total distance divided by total time taken. Let's suppose a car is moving from point A to point B. The distance, total distance you have covered 120 meter in 1 minute. See, meter is as a unit, but minute is not as a unit. You will convert into seconds. So you know that total distance is 120 and time 1 minute is equal to 60 seconds. So the speed is 2 meter per second. That is the average speed. Next is acceleration. Acceleration is belong to velocity because acceleration is a vector quantity. So the rate of change of velocity is called acceleration. Or you can say that change in velocity per unit time is called acceleration. Change in velocity. This word is very important. Change. So velocity should be change. If velocity doesn't change for constant velocity, acceleration will be zero. Understand? So let's suppose a car is moving with initially you have noted about this speed is 20 meter per second. After 30 seconds, it is achieved 50 meter per second. So total how much change in the speed? 50 minus 20 means 30 meter per second. In 30 seconds, half minute. So you can use you can calculate the acceleration by using a is equal to a is acceleration, v is the final speed, that final velocity, u is the initial velocity divided by time. So you know that change in speed is 30 meter per second. So 30 over 30 is 1 meter per second square. You know, understand the meter per second square. So you know that yeah, unit of speed is meter per second divided by second. Meter per second per second. So it is meter per second square. So there are two types of acceleration. Sometime the velocity of the car is increased, sometime the velocity of the car is decreased. So acceleration may be defined as positive acceleration or negative acceleration. If you take the example of this car, for example, the initial speed is 20 meter per second, the final speed is 50 meter per second. Speed is increasing. So in this case, the acceleration is positive acceleration. When, for example, when this car is traveling towards left to right, right to left, sorry. So first the speed is 50 meter per second. After that, speed is decreased to 20 meter per second. So speed is decreased. That is called negative acceleration, and the speed is always in the negative. Acceleration will be in negative. Sometimes it is called deceleration, retardation. Normally, we use this word deceleration. Deceleration means decreasing velocity, decreasing acceleration. In next video, we will discuss the very important part of this chapter, that is speed time graph and distance time graph. And many questions in the paper, final paper, are belong to graphs. So graphs are very important to understand. I will make a separate video for that. Hope you understand my lesson. If you have any question, ask me in comments. And if you want to uh, take online session, so you can also contact with me. And if you need this in PDF, you can ask me in comments. Goodbye.